right. Hi, everybody. This is the walkthrough video for Monday. Today is November 11th. And weirdly, we are at the point in time where we are ready to start thinking about our bell work. This is page 6, I forgot to say. So let's go ahead and set up our bell work. You're going to get a yellow worksheet in class. You'll complete these most weeks with us, and they are a way for us to begin and end class and do that recall practice we were talking about last week. So you're going to start by setting up your bell work with your name and period. And I keep messing up the page because I had a difficult time. It is page 6. Bell work is page 6. So now you've got the page set up, you're ready to look at the try and the week. And we always try to make it so that you have the trimester and the week up on the board when you walk in. And so you're able to use that information to fill out that this is page 6 and it is try 2 week 2. Sorry for the delay. Now, the next thing you have to take a look at is the date of the thing that's happening, right? So today is Monday. We take a look at the slides. You'll see it's Monday, 11/11. And so that information goes here. Now, after that, you're going to get a thing to do, a task, right when the bell rings. And that's why you need to have your electronic devices out with your bell work out ready to go. And today is saying, what's one thing that's going well for you right now? So you're going to write one complete sentence or more than one complete sentence about it. Be sure to include a capital letter, a complete thought, and correct punctuation at the end. So here's one. Somebody has history this trimester and they really enjoy learning about the past, which is great for them. That's really exciting. I don't know why it says history. It should say history. There we go. So the next thing that you're going to think about is what goes in the what spot. There's a homework spot in case you realize you have to finish some work. But our what is a direct copy of the question of the day. And in this case, it's how does the information in DNA become a protein? So we're going to learn about 2 separate processes this week, transcription and translation, and practice them together. So let's take a look at our colorful table of contents page. This week, you've got to, I managed to fill in the bell work, and then I forgot the assignment that you did the other day because they have very similar names. So now they're both in there. So if it's highlighted in yellow, it probably means that you need to copy it onto your blue table of contents page. So please pause the video and put those 2 things there. All right, how do you find this? This is the weekly agenda for today. It's always in this yellow table of contents page. And so it updates automatically, and then you can click through and say, okay, I don't know what that assignment was. Oh, it's this assignment. That's what it looks like. I can print it out an extra copy if I need to, or I can go look for it in my belongings. So, all right, so where have we been? We talked about how changing the shape of a protein means it can't do its job. And we talked about pH in the lab, but also like changes in DNA change protein shape. And that can mean that if you have a mutation, a change in the DNA, you end up with a protein that doesn't fold the same way, doesn't have the same job, and therefore does not do what it's supposed to do in the body. And what we're going to investigate before we look at some case studies of diseases that come about from mutant proteins is looking at the process behind this arrow. How do you get from DNA to protein? Well, it turns out we know that process. There are 2 pieces of it, transcription and translation. And today's assignment, which is called DNA arrow mRNA arrow protein, is going to help you think about that. So to do this assignment, in which by the end you'll describe and model how the information in DNA serves as the instructions that code for proteins, you're going to go ahead and start here and move through the assignment, reading and doing what it tells you to do. Now, you don't have to find the digital link that's here. You actually can click this purple link and it will also show up so that you'll be able to see that when the time comes. So today's assignment is asking you to watch a little video, do a little work, and practice lining up making messenger RNA from the DNA and then using an anticodon here to be able to bring over a protein. So after today's assignment, you will be ready to do several things. If you click through, you'll see that there's some information that you'll do with the codon matching. And then you're going to practice doing it on paper. So the way it works, it says first, fill in the complementary DNA strand using DNA-based pairing rules, which we learned about the other day. Then it says fill in the correct mRNA bases by translating the bottom DNA code. So you're going to take this one, and this is A, so this is T. T bonds with A, and you'll go through and remember that matching here. Now, at the end, you'll need to flip back and forth a little bit because you're going to have to read this codon table. So let's say you get U, C, G. Let's say you get U, C, G. So the first base is U. So you're going to look here. It's somewhere in this row. The second base is C, so U, C, this is the overlapping thing. And it doesn't matter what the third base is, all of those are serines. So in this spot up in the assignment, you would write SER if those codons were what you had here, and that's what you were doing. Once you write the word stop, you don't have to make any others. So once you get a stop codon, as you saw in the simulation, it's done. You're all taken care of. So that's what we're up to today. There's some questions like this on the worksheet. I think I'm going to give you the answers to these during class tomorrow, so you'll have access to thinking about those. Where have we been? So by the end of class, you'll know a little bit more about how you get to DNA to protein. You'll know that transcription is the part that goes from DNA to mRNA, and that translation is the part of the process in which that newly formed messenger RNA strand becomes the information in proteins and gets that three-dimensional shape. So where we're going is thinking about what happens to people when this happens. So when you get this mutation and you have these processes happen, like what happens as a result? That's where we're going. So here's your cool down. In messenger RNA, if you have a DNA and you're making messenger RNA, you are going to make one of those. If you are making DNA and you have an A, you are going to put that down. So those are the words. You're going to copy down the whole idea and complete them. And I've given you the answer here. All right, that's it for me. I hope you're doing well out there. I also wanted to say we know that the freshmen are going to a matinee on Friday. You're going to go to Lord of the Rings. We know that. We've got a plan for you. All right, that's it for me. Hope you're doing well. See you soon.